we now continue with this calculus problem. Remember, we were trying to find the absolute maximum of this function over the interval 0, 1. We tried to find all critical values, and we took the first derivative and get the alpha star is equal to 2p minus 1. Then what's the next step? Once we get alpha star over here, a very important step is to determine whether this alpha star is inside the interval. If alpha star is in the interval, then it is a candidate. If it is not in the interval, then this alpha star is not a candidate for the maximal value. So this is an important step. So let's write down over here. So we need to determine whether this alpha star is inside 0 and 1. Because we have a parameter p over here, so we are really solving two inequalities. This is the one we want to look at. We want to look at whether 2p minus 1 is less than 1 or bigger than or equal to 0. So this is the one we are asking. Okay. Now, if we look at 2p minus 1 less than or equal to 1, then it means 2p is less than or equal to 2, or p is less than or equal to 1. Now remember, our win probability p does satisfy this condition, so we know 2p minus 1 is less than or equal to 1. But how about the other inequality? We have 2p minus 1 needs to be greater than or equal to 0 if we want alpha star to be inside this interval. Now if you look at this one over here, that means 2p needs to be greater than or equal to 1, and p is greater than or equal to 1/2. Now remember, the restriction on p is between 0 and 1. So this condition over here indicates that we need to look at the problem for different parameter regions. So we need to divide the situation into several cases. So now we have this one over here. So we have two cases really. Two cases. Case 1, if we have p greater than or equal to 1/2, then alpha star is a candidate because alpha star is equal to 2p minus 1 is inside this interval. And then we consider the problem. And we also have the second case. If p, this parameter, is less than 1/2, then alpha star is not a candidate. This one is not inside 0 and 1. So how can we find the maximum value of f of alpha? Then we just need to look at, in this case, we only have two endpoints as our candidate. So we need to only consider two values, f of 0 and f of 1, and try to see which one is bigger. And the bigger value is our maximum value. Okay. Now, this second case is easier to consider. It's in a sense not a very typical situation. So we're going to look at case 1 only in this case and to see how we're going to finish. So this is the case 1. Case 1 over here is the parameter region. We say p is bigger than or equal to 1/2. And then we have alpha star is inside, so we need to calculate this f of alpha star. F alpha star over here, we plug it in, and then we have p and log 1 plus 2p minus 1, and then we have over here 1 minus p, and we have log 1 minus 2p minus 1. If we simplify, this is log 2p, and over here is log 2 minus 2p. So after we simplify this one, we actually have log 2 and plus p log p and plus 1 minus p log 1 minus p. It's a pretty interesting number, but somehow it's not easy for us to see if this number over here is greater than f of 0 or f of 1. We can look at f of 0. When you plug in 0, we have log 1 is 0, so this is going to be simply 0. You will see that. How about f of 1? If we look at this expression, this is p log 2 when alpha is 1. But here, this is the part that's getting trouble. It's log 1 minus 1 is log 0. We know it's not defined. But if alpha is approaching 1, then this is negative infinity approaching. So really, this one over here, we can just write down it's going to be negative infinity, even though this is just a notation over here. So the only thing we need to know is whether this value is bigger or this value is bigger. Now we know log 2 is bigger than 0. This is for sure. But this part over here is less than 0 because log p and log 1 minus p, they are both negative because p and 1 minus p are less than 1. So they are both less than 0. So it's unclear whether this one actually is positive or not. Of course, if we use a little bit more calculus, we can show this one actually over here is positive. But this detail, we're going to leave this detail also for you to show that c is equal to, let me call this constant c, log 2 plus p and log p and plus 1 minus p and log 1 minus p. We can show that c is greater than 0 if p is greater than 1/2. Now, if p is exactly 1/2, you will see this is 1/2 over here and this is 1/2 over here. C is going to be 0. So that is the situation. Now we know f alpha star is the maximum. So we know f of alpha star is maximum. That means the maximum value is reached at this critical value. So this is one way, but the detail is left out over here. Let me try to use another way. This is the way that we also discussed in calculus. We can also use the second order derivative test. So in order for us to see whether alpha star is maximum, we look at the second derivative. Second derivative sign tells us the concavity of the function. If we can show second derivative is negative, then it concaves downward, and then alpha star is going to be a maximum. So we take the second derivative. Recall the first derivative over here is, we recall it's p over 1 plus alpha and minus 1 minus p over 1 minus alpha, right? So we're going to take the derivative one more time, and that's going to be negative p over 1 plus alpha squared. Now take the derivative very carefully. Remember, this is 1 minus alpha to the negative 1. 1 minus alpha, take the derivative, we have another negative sign. So this one actually is negative 1 minus p and 1 minus alpha squared. Because of the chain rule, that's what we're going to have. If we look at this one, this second order derivative is less than 0. So using the second order derivative test, we have also f of alpha star is the maximum value, And now we can find what is the optimal value v1 of x. We will do that in part 3.